everyone, I am Shalaka Deshpande. Welcome to my YouTube channel. Our today's topic is setting interrupt priority in 8051 microcontroller. Okay, so in one of my previous videos, I have told you what is interrupt, what are the interrupt enable registers. Okay, so I have given you the general idea of what is interrupt and what is interrupt service routine. Okay, so in this video we are going to see the interrupt priorities, how the interrupts are assigned priorities. Now see, interrupt occur asynchronously, means interrupt can occur at any time. They are asynchronous, occurrence can be asynchronous. So what will we do if the two interrupts occur at the same time? There is one microcontroller and there are two interrupts which occur at the same time. So which interrupt will be serviced first? How it will be decided? The answer is interrupt priority register. So these are the bit details of interrupt priority register. Okay, so there are various bits inside the interrupt priority register and we are going to study that in detail today. So if those bits are set to 1, then that interrupt is assigned the highest priority, and if those bits are set to 0, then interrupt is having a lower priority. Okay, clear? So let's see the bits in detail. RSD, 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 these are reserved. Then we have PS. PS is serial interrupt priority. Okay. Now see what is serial interrupt, that also I have explained in my previous videos. You requested to watch it. Okay. Then we have PT1, timer 1 interrupt priority. Then we have PX1, external 1 interrupt priority. Then we have PT0, timer 0 interrupt priority, and PX0, external 0 interrupt priority. So these are the interrupts which are supported by 8051. Two timer interrupt, two serial interrupt, and two timer interrupt, two external interrupt, and one serial interrupt. Okay, clear? So see, one more important thing which is to be noted, that see, there is a mechanism in 8051 in which these bits are latched. The status of a flags, these bits of this IP register are also called as a flags, and status of those flags are latched in 8051 microcontroller. Okay, means they are stored in the latch D flip flop. Okay, so what exactly happens? See, during S5 P2 of every machine cycle. Now what is machine cycle? What are T states? What are the clock pulses? What is S5 P2? Now see, these must be questions before you. So I request you to see my video execution speed of 8051 microcontroller. See the video related with execution speed of 8051 microcontroller, Shalaka Deshpande. You will understand what is S5P2. S5P2 is a state 5 pulse 2. During that time slot, all the flags of these interrupt priority register are latched. They are latched and their statuses are checked. Okay, they are polled, and if one of the bits during polling, if one of the bits is found to be enabled, if one of the interrupts is enabled during that, then the interrupt system transfers the program control to interrupt service routine, that is ISR, related with the corresponding interrupt. Okay, the program flow transfers to ISR. So it happens during S5P2. The flags are checked during that. Okay, so this was about the S5P2. Now what happens if the two interrupts of equal priority occur at the same time? Means there are two interrupts, both are having equal priority and they occur at the same time for a microcontroller. What will microcontroller do? During this situation, internal polling plays an important role. Okay, now what is internal polling? I will explain you, be patient. Now see, here one more important thing is that what if the two priorities, what if the two interrupt of different priority occur at the same time to a microcontroller? See, in that case, interrupt which is a higher priority will be serviced first. Okay, and after that, interrupt which is of low priority, it might get lost. I mean to say, because there is no such mechanism. So the interrupt of obviously which is having higher priority will be executed. And suppose if a low priority interrupt is running and at the same time high priority interrupt comes in, the program switches to high priority interrupt. Okay, so high priority interrupt can always interrupt the interrupt which is of a low priority. Okay, clear till this? Now see this 8051, it is having priorities at two levels. The priority is at two levels. First is the interrupt priority register. Interrupt priority register decides which interrupt will have highest priority and which interrupt will have lowest priority. For example, suppose PS, serial interrupt, this bit is 1 and all other interrupts are all other bits are 0, then the serial interrupt will be given highest priority. Okay, and if this is 0 and PX1, external one interrupt is 1, then all other interrupts will be given lower priority and external interrupt 1 will be given higher priority. So interrupt priority register decides which interrupt will be high priority and which interrupt will be low priority. This is one level. Now second level of interrupt priority is internal polling. Now what is this internal polling and when does this occur? See, as I told you, when the two interrupts of equal priority occur at the same time, internal polling comes into picture. During internal polling, the status of flags which are related with interrupt is checked, and a flag which is enabled first is served first, means flag which is called first is served first. So what are the levels of that priorities during the internal polling? When internal polling is happening, how the status of flag is checked, what are the levels, priority levels? Let's see that. You can see external 0 interrupt is having highest priority during internal polling. Then we have timer 0 interrupt, then external 1 interrupt, timer 1 interrupt, and last lowest priority is the serial interrupt priority. So serial interrupt is having lowest priority. So in case of internal polling, first called is first served. Okay, so these are the priority levels, means which flag is first called, the sequence of calling the flags, checking the status of the flags, that sequence is given here. Okay, so I hope you liked this video. If you have any doubt, you can ask me in the comment section below, and I request you to see the video of execution speed of 8051 microcontroller by Shalaka Deshpande before seeing this video. Okay, so that you will understand better. So that's all about today's lecture. Please like, share and subscribe my channel. Thank you for watching. Bye bye.